Hi, Mr. Corsi here. In this question we're given a diagram with various angles and lengths, and we're asked to calculate the side DC of triangle BCD. So it's basically a triangle problem. Let's look more closely at the triangle and what we know. 37 degrees, this is 20 centimetres. It's certainly not a right angle triangle, so we can rule out Pythagoras' theorem, we can rule out using SQA. That leaves us with the sine rule and the cosine rule. So what exactly do we know in this triangle? Do we know any more other than just the 37 degrees and the 20? Well, look at this 75 degree angle. There's a straight angle, ABC. That's a straight line. So the whole angle around B there makes up 180 degrees. We've already got 75 degrees of that. So 75 from 180 would be 105. So that's one other angle that we can put in, 105 degrees for that. So we certainly know these two angles, and obviously we could work out the third angle by adding these two up and taking it away from 180. The angle sum of a triangle is 180 degrees. But it's interesting that we've got a side length and the opposite angle. We're interested in finding DC, and we know the opposite angle. That would imply the sine rule. Sine rule involves length of a side, sine of the opposite angle. There's the sine rule for a triangle ABC. Now in this triangle we would use B over sine B equals C over sine C equals D over sine D, because we have vertices B, C and D. And remember that opposite angle C, this side is little c, opposite angle B, this is little b, and opposite angle D, this is little d. So it's worth looking at the this form of the sine rule and seeing, what do we know? We know D is 20 centimetres. We know angle D. We're trying to find little b, that's side DC, and we know the angle opposite that. We also know angle C, or we could calculate it, but basically this is the part we're not interested in. So this now tells us to solve this problem, we're going to use B over sine B equals D over sine D. And let's put in everything that we know. We don't know B, but we're trying to find it. We know angle B is 105. Little d is 20. Sine D, we know D is 37, so that's sine of 37 degrees. So how do we get B on its own? Well, we're dividing it by sine 105. What action do we take to both sides to get rid of a divide by sine 105? Well, we multiply both sides by sine 105 to get rid of that. So the action we take to both sides of this equation is multiplying it by sine 105. Now we do that on the left, we get B on its own. We do that on the right. If we multiply a fraction by a number, the number appears on the top of the fraction. So it's 20 times sine 105 divided by sine 37 degrees. And that tells us the calculation we need to make to find this side DC. So let's get into that calculation. 20 times, now the sine, we make sure your calculator's in degrees for this, sine 105 times, divide by sine 37. So there's the calculation. Having made sure I'm in degree mode, that's what I get. So it's 32.100 and so on. Now I would suspect, since they're not telling us what accuracy to give this to, then the side DC we could say is approximately 32.1 centimetres. And the accuracy is to 1 decimal place, or 3 significant figures, whichever you prefer. So that's Mr. Corsi signing out, and thanks for watching this video.